For those of you who are of a certain age, that is old enough to know about the 1993 Fusarium Headblade epidemic, you'll know what I'm talking about. So in that year, we had a very, very late spring. People got planted late, and then we had an excessively moist summer where there were frequent rains. And also during this time, there was a buildup of inoculum. So people really started to practice some minimum tillage, and that put a lot of residue in the field. And also the fact that we didn't really work on breeding barley for resistance to Fusarium because we really didn't have to work with that disease for a very, very long time. So all those factors came together in 1993 and caused this watershed epidemic. And anybody who lived up in the Red River Valley, like I did over in the Fargo area, knows what a dramatic epidemic that was, that it really shook the fabric of everything from Main Street to all the rural communities. So this is a disease, again, caused by a fungus. There are several Fusarium species that cause Fusarium head blight of both barley and wheat. The primary one is Fusarium graminearum. So this one attacks all three cereals of wheat and barley and oat, and it also attacks corn, causing a stalk rot and also an ear rot. And there's a very important thing to keep in mind when you're growing small grain cereals, and that is to not rotate small grain cereals after corn because of the tremendous residue that corn stalks provide in terms of the Fusarium inoculum to infect the small grain cereals. So that is really the number one thing, is not to plant small grain cereals after corn. So what we're trying to do in terms of developing resistant varieties is that we're screening literally thousands of varieties for resistance in these inoculated nurseries. So over the past decade or so, we've screened upwards of 30,000 different barley varieties from all over the world, trying to look for that one or two that has the right characteristics and also the right resistance that we can use in our breeding program. So this is how we inoculate the materials. We grow the barleys in these rows, and we have to actually use netting to stake up the plants, because if they lodge, that really causes them to be unnecessarily high infection on the plant. So we have to make them stand up as they would in the field. And then we inoculate by infesting kernels and then throw them on the ground, and then the fungus sporulates from that area and then infects the heads. So you can see, as you look across here, you can see the diversity of barley types that we have here, from tall ones, short ones, red ones, extremely short ones that are super susceptible like this one. So we're trying to get the full gamut of material that we can possibly try to identify resistance. And so resistance is a major component to trying to control this disease, but really, if we're going to control this disease in the best way fashion, we have to use all three methods of deploying resistant varieties, using residue management or other cultural control practices, and also apply fungicides. So all three of those are going to be needed to really try to get this disease under control. And of course, with barley, specifically for those people who are trying to make malting grade, the maltsters and brewers have a really low threshold for what they'll allow in terms of the vomitoxin or deoxynivalenol. That's the mycotoxin produced by the Fusarium fungus. There's just a certain low level of 0.5 parts per million that they really allow in any barley that goes into the grain elevator, that ultimately will result in malt and then afterwards beer. So that's why we have to breed not only for resistance to the symptom, but after we take the disease ratings, we have to harvest the grain and perform mycotoxin tests on it to see what level of mycotoxins might be present in the grain. What I have here is a two-row barley. I'm just rotating it a little bit, but if you look close up, kind of the first symptom you'll see is a little bit of a yellow to brownish discoloration, and then eventually that's going to turn a little bit darker. So you can see that much more darker pigment in the infected kernel, and that's very characteristic of the symptom of Fusarium head blight on barley. Wheat has a very different symptom. It's a lot more tan or bleach color than these early symptoms on barley. Now, I spoke about two-row barley. So for some 100 years in Minnesota, we've had a barley breeding program for six-row barley. But as of about 2 years ago, both the major brewers and the microbrewers decided that they really prefer the two-row for malting and brewing. So now our breeding program has switched over to two-row. But I just wanted to show you a six-row barley infected with Fusarium head blight. And one of the problems that we have with Fusarium head blight in six rows is that quite often, because of the close proximity of the kernels to each other, we often get a triplet of kernels infected. So in this case, perhaps there was an initial kernel in the middle infected, and then it spread to the lateral kernels. So this common triplet infection was what we used to see quite a bit on six-row barley. We're hoping that with the change to two-row barley, we would see less percentage of infection on the two-row types. And just to give you an idea of what happens when you have extremely severe infection of Fusarium head blight, you can have the entire spike be infected with Fusarium, just turning it all straw brown, as if it was just looking like it turned senescence through maturity. But actually, in this case, if you look closely, there's sort of a little bit of a darker discoloration than the natural sort of tan senescent color, and this is all killed by Fusarium head blight. And of course, we worry about the level of mycotoxins in this material, so even sometimes just small percentages of infection can lead to unnecessarily high levels of mycotoxin, which can dock you from a premium for malting barley to getting discounted for feed barley.